Okay, so the next topic in logic we're going to talk about is proofs. Specifically, we're going to do algebra proofs. So, to like solve equations in algebra, we know we use specific properties and rules that we're allowed to use. So this is just a list of all the rules that we're allowed to use to solve algebra equations. So some of these should look familiar to you, like distributive. I see the parentheses. We know that's when we do distributive is when we multiply into the parentheses. Addition, I should be seeing like, oh, there's a plus sign right there. Subtraction is a minus sign. Multiplying is the little dot for multiplying. And division, they use the divide sign. The other ones you will be able to recognize because they're going to give you specific examples and you have to say like, oh, which property did they just show? So those are the kind of things you're going to be looking for, like what was there parentheses in it? Was there a plus sign, a minus sign, multiplying, dividing? And these other ones could possibly be there as well. So the first thing you're going to have to be able to do is identify. And you are going to be given this list on the test, so don't like freak out. You don't have to memorize it. So if I look at the first examples, which property is being used? So when I look at this, I'm like, wow, that's a lot of stuff. I don't really know what it means. But let's look. How many equal signs are there? There's 1, 2, 3 equal signs. And it said if and then. So let's look back at our list. Which ones have 3 equal signs in it? Only one of them that I can see right here. A equals B, B equals C, then A equals C. That's 3 equal signs. That's how I know that one's the transitive property. So I'm going to go ahead and type that. That's transitive. Wow, that's big. Here we go. So we're going to type transitive property. Let's make that a different color because we can. Okay. So that's all you have to be able to do is pick out which property is it. So, oh, there were 3 equal signs. That means transitive property. The next one, it says if 3x equals 27, then x equals 9. So in ones where there's actually numbers, like clearly something has changed from the first part of the sentence to the second part of the sentence. And I don't really see what's changed. Like I see, oh, there used to be a 3 in front of the x and now there's not a 3. Well, how did they get the 3 to go away? Oh, well, if you were solving this equation right here, how would you get 3 to go to the other side? Oh, I would divide by 3, right? And when I do 27 divided by 3, I get 9. So that tells me, oh, if that's what they did to get this, then that means that's the division property. I don't even need to look at the paper to know that, because they're just like solving an equation right here. And all they want to know is what step did they do to go from this to this? Oh, they divided. In the next example, it says if x equals 10, then x plus 13 equals 23. So I see that they're kind of doing the opposite of this. They're starting out with like the answer x equals 10, and they're going like, it's changing. Like it used to be x alone, and now it's x plus 13. So, if it's a plus sign, if I'm seeing a plus sign, well, to go from 10 to 23, did they do plus 13? Yeah, they did. I see a plus sign. If I look at this list over here, in the addition postulate, there was a plus sign in it. Look, plus sign, okay? So the answer for that one is addition property or postulate or whatever it says. Okay? You're pretty much seeing how does it change from the if part of the sentence to the then part of the sentence. This one they had to divide. This one they did plus 13. In the bottom example, if f equals g, then g equals h. So I'm seeing there's 2 equal signs. Okay. And it's not really numbers, so I'm not thinking it's going to be like addition or division or subtraction or anything. It's got to be one of the different ones that we're not used to. So there's 2 equal signs. There were no parentheses. This has 3 equal signs. This was all the ones like addition, subtraction, multiply, divide, like we're used to those. The one that has 2 is right here. And basically what symmetric property means is that if you know, like in this one, oh, the A is written first and then B, you can flip that because the equal sign, it's equal both ways. When A equals B, yeah, you know it works the other way as well. B equals A. So that had 2 equal signs. This had 2 equal signs, and that's what it's talking about. If F equals G, then G equals H. So the answer for that one was symmetric property. So that's pretty much all there is to like the matching. Definitely have the list of properties in front of you. That will make your life a lot easier. Okay. The next one is actually doing a proof. Okay, so when I say a proof, all that means is they're going to give you an equation, and then they want you to solve that equation, and they want you to list out every single step you did to solve that equation. So so there's 2 columns. There's the given column, so this is where they're writing the equation, and then the justification. How did you know that this was what you were supposed to write there? So first of all, the first justification, every single time, the first justification, you always start out with given, because you know that this is true because it was given to you. Okay? Now, if I was going to do this myself, I would take this equation, I would write it off to the side. So I'm going to write it over here. 2x plus 7 equals negative 4x minus 65. So all they want you to do is solve this equation. So that's what they did in here. Oh, the first step you're supposed to do when you solve the equation is move the x's together. How did they move the negative 4x over here? Because I see the x's ended up on this left hand side. Well, they did plus 4x. Plus 4x. Okay? 4x canceled out. Negative 65 is left. Positive 7 is here. 2 plus 4 is 6x. And if you look, this right here is what they wrote here. Okay? How do I know that that's true? What property? Well, what did you do up here? What was this step? I added. So then that is what you write over here for your justification, is add or addition property or just addition. That's fine. Okay? So this middle step is what goes for justification, and this step right here, that's what goes in these blanks. Okay? So what's the next step we would do? Because now you have to fill in both columns. Well, the next step I would do would be to move the 7 over to the right hand side. How do I move 7? Well, I'm going to minus 7. Minus 7. Okay? What do I get? Well, the 7 and 7 cancel out. I'm left with 6x. Negative 65 minus 7 is negative 72. So then this is what I'm writing right here. 6x equals negative 72. And what am I writing over here? Well, that's coming from this step right here. What was this? Oh, that was subtraction. So that's what I'm going to write. Subtract. Subtraction. Whatever. Okay? And it's nice because they are always going to give you exactly how many blanks you need. So I can see, oh, well, I only have one more step left. How do I solve for x now? Well, oh, I have 6x. How do I get x alone? I divide by 6. Divide by 6. And when I do that, 6 divided by 6 is 1. Leaves me with x equals negative 72 divided by 6. You would type that into Desmos, and it would tell you negative 12. So, oh, I'm going to put negative x equals negative 12 in the last box. And what property did I use to get negative 12? Well, what step did I just do right here? I divided. So I'm going to put either divide or division property. Okay. So it's just solving equations, and after every step you write down, well, what did you do? What did you do? What did you do? Okay. If you need to, go ahead and watch the video again. Otherwise, you're going to start the formative.